Starship gets a launch date, an Australian space company is about to make its debut flight, a venerable asteroid-hunting satellite meets the end of its life, and Dragon is about to reboost the ISS. We'll have all that and a whole lot more this week in spaceflight. Starship has a launch date, and it's a whole lot sooner than a lot of people expected. Right off the bat, that date is November 18th. We'll get to the details later, but just so you know, mark your calendars for that day because that is the date that it's planned to happen as of right now. Okay, so let's recap what happened. We first heard about this launch date thanks to a notice-to-air mission for the launch of Starship over Mexican airspace, which pointed to November 18th as the earliest potential launch date. Moreover, it also indicated one big change that's happening for this flight, which is that it'll happen in the afternoon local time instead of in the morning right after sunrise. Within hours, SpaceX officially confirmed this date on both X and on its website. Starship's sixth flight is currently targeted for launch as early as Monday, November 18th, within the 30-minute window that opens at 4 p.m. Central Time or 2200 UTC. As with every SpaceX launch, the company's webpage for said launch contains information about what the launch is all about. But for Starship, of course, the page contains a lot more information than, say, the 200-second Starlink launch. At first glance, Starship's sixth flight will be rather similar to the previous one. For example, we'll still have the rocket heading out over the Gulf of Mexico, with the booster returning back to the launch site for a catch, and the ship threading the needle between Florida and Cuba, heading for a reentry over the Indian Ocean. There'll also still be a hot staging, we'll get to see the ship coast in space, and it'll attempt a soft landing in the ocean via a flip and landing burn as we've been used to on the last two flights. The requirements for the booster catch decision will also be like previous flights, where automated health checks on the booster and the tower need to be good for the booster to be approved for the return to the launch site. Similarly, the flight director will still need to send a manual command to the booster during its boost back burn to approve that return. However, there are also some differences compared to the previous flight. For example, SpaceX says on its website that teams have performed hardware upgrades that add additional redundancy to the booster propulsion systems, increase structural strength at key areas, remember that broken chine on Booster 12? And also shorten the timeline to offload propellants from the booster after a successful catch. Now, these kinds of upgrades will be fundamental to reducing the amount of damage that the booster suffers during reentry, making it more resilient and, in turn, more rapidly reusable, which is a key goal for SpaceX. As for the ship, SpaceX says that it'll once again try to perform an in-space relight of one of its 6 Raptor engines during the coast phase, one of the goals that the company wasn't able to achieve during Starship's third flight back in March. Back then, the main reason the in-space relight wasn't attempted was that Ship 28, the ship for that mission, lost roll control during its coast phase, and the onboard computers decided to abort the relight. This loss of control is obviously no longer happening, as Ship 29 and Ship 30 demonstrated over the last 2 flights, and an in-space relight seems more doable this time around. Such a test will demonstrate that Starship can safely perform a deorbit burn after completing an orbital mission, ensuring that SpaceX can control where it reenters, be it in the middle of the ocean for disposal, or at a pinpoint landing anywhere in the world to be reused again. Ship 31 will also incorporate further tests of Starship's heat shield system. On top of the now common materials testing that SpaceX has been performing over the last few flights, the company's teams have also removed extensive sections of heat shield tiles on the sides of the vehicle. SpaceX says that these are the locations that are being studied for catch-enabling hardware on future vehicles, something that we actually already anticipated on our episode of This Week in Spaceflight following the last Starship launch. For this flight, SpaceX also performed more materials testing and experiments on Ship 30. The company confirmed that they had installed tiles covered in aluminum in certain places on the side of the vehicle. These would allow SpaceX to understand how hot it gets in those places as aluminum melts at the temperature that stainless steel starts to become weak. In addition to the heat shield testing, SpaceX also says that Ship 31 will, quote, intentionally fly at a higher angle of attack in the final phase of descent, purposefully stressing the limits of flap control to gain data on future landing profiles. Now, this is a bit more unclear as to the specific reasoning why they want to get that data out of Ship 31, but knowing the limits of how a ship can maneuver itself through the atmosphere is obviously in itself quite an important goal. Also, as mentioned earlier, the launch will happen in the afternoon local time, which means that that when the ship lands in the Indian Ocean, it'll be daylight, and that will allow SpaceX to better observe the ship as it comes in for a landing. Of course, along with the mission information, SpaceX also released the timeline of events, which gives us some insight into how things have changed relative to Flight 5. Since the profile is largely the same, the differences are very subtle and just a matter of seconds for the first portion. For example, the booster landing burn will begin 5 seconds later, but it will be 1 second shorter. The estimated time between the booster being transonic and the landing burn start has also shrunk from 25 seconds down to 13 seconds. We can also see that SpaceX is aiming to perform that Raptor relight test 37 minutes and 46 seconds into the flight, which would be 3 minutes earlier than what it was planning to do during Flight 3. The ship will also enter at the same approximate time, which is only 50 seconds earlier than Flight 5 and 12 seconds earlier than on Flight 4. So overall, while some things have been tweaked, the timings will largely be the same. SpaceX's announcement was also accompanied by one of the company's traditional post-flight recap videos, which included new angles of Starship's 5th test flight. For instance, this upward-facing camera on the booster that captured this amazing view of hot staging with the ship flying away as the booster flipped back for boost back burn. You can even see in the video the ship's center 3 engines gimbaling inward to their normal position after hot staging. This same upward-facing camera also caught views of the booster's descent through reentry and during the catch, which we hadn't seen before. Another really interesting new view that we hadn't previously seen was from the ship's flaps, and it was of the landing burn, which we had only seen for a few seconds during SpaceX's livestream. One of these camera views even has water splashing on the aft flaps as the ship landed in the ocean. Now, as you may have noticed, this Starship launch comes very quickly after the previous one. As of our day of publishing, it's only been 26 days, and we're just 10 days away from the planned launch day, so that means this will be the shortest time between Starship launches so far. This is thanks to the flight not needing any license modifications due to the launch license for Flight 5 already covering all that's planned during Flight 6. As usual, we'll be covering the launch live, but we'll also be featuring our countdown to launch live streams starting next week. So if you want to keep up to date with what's going on in the lead up to the flight, make sure to do all the usual YouTube antics like liking, subscribing, and hitting the notification bell so you don't miss anything. It's free, and it also helps us to reach more people. And now let's take a look at some other stories across space, starting with Starship's engine, Raptor. Part of the key to Starship's future successes involves testing Raptor engines left, right, and center, and sometimes those tests end in a rather violent way. This week, we saw what clearly looked like an explosion of a Raptor engine on the vertical stand at SpaceX's McGregor test site in Texas. This stand is one that we think is solely dedicated to testing Raptor 3 engines, so if that's correct, this might have been the first explosive end of one of those engines that we've been able to witness. Now, these explosions are not very common. We may only see 1 or 2 every few months, and then between that, maybe hundreds of tests have been performed. But these explosions are also not entirely unexpected either. After all, it is a test site. Sometimes SpaceX pushes their engines to their limits, and other times they just discover how not to fire a full-flow staged combustion cycle engine. While we may not know which type of explosion this one was, one thing is for certain: they'll always learn from it one way or another. Staying at McGregor for a bit, this week we also had a sad farewell to the test site's iconic tripod stand. Over the past few days, we've started to see a crane taking apart the tanks and the components of this test stand, and it doesn't look like this is for any sort of reconfiguration. Now, if you remember from recent weeks, this was the site of some epic Raptor tests, such as the nearly 15-minute long Raptor firing back in September. Just a couple of weeks ago, it also saw multiple firings and relights of the same Raptor engine in a short time over the course of 2 days. This stand dates back to the late 1990s when Beale Aerospace built it to test its own engines. After the company stopped operations in 2000, it sat dormant until SpaceX bought the site for testing of its Merlin engines, as well as its Falcon 1 and Falcon 9 rockets. Now, we have an epic tribute video coming up for the test stand, where you'll be able to learn more about its history. So stay tuned for that in the next few days. This week, a team of astronomers released an interesting discovery about the star Vega. Led by Skylar Wolf from the University of Arizona, the team combined the forces of the Hubble Space Telescope and the James Webb Space Telescope to observe the star Vega, which we know is surrounded by a disk of dust from its formation. What she and her team found out, though, is that it's a lot smoother than we originally thought. Normally, when stars form, there's leftover dust and rocks that surround it in a disk. All of this dust and rock, more often than not, clumps together to form planets of varying sizes, turning into clear, empty areas on the disk around said star. But for the star Vega, these empty areas aren't there. indicating that there are no major bodies orbiting the star. And this is quite puzzling because Vega is already old enough to have had plenty of time for planets to form around it. Other similar stars with disks of dust that we've observed do have these empty rings, indicating that there are planets there. This new piece of research certainly challenges the understanding of planetary formation and evolution, and confirms once more that there's a whole lot more to know about our cosmic neighborhood. After months of waiting to receive regulatory approval, Gilmour Space is finally cleared for launch for the first privately developed rocket from Australia. This week, the company received a launch permit from the Australian Space Agency to launch its Eris rocket from the Bowen Orbital Spaceport located in North Queensland. Gilmour's Eris rocket is a 3-stage small-lift launcher with the capability of launching a couple hundred kilograms into low Earth orbit. The rocket uses hybrid propulsion on its first 2 stages, which the company has tested extensively over the last few years. The rocket itself has actually been at the launch site for the better part of the year, awaiting regulatory approval. In the meantime, Gilmour successfully completed a series of tests prior to launch, including a wet dress rehearsal of the rocket where all countdown events were carried out up to the T-10 second mark. If all cooperates, Gilmour hopes to launch Eris as soon as early December, so we'll be keeping an eye out for when that happens. Now let's take a look at the space traffic this week and see what's coming up next week in spaceflight. Starting off the week on November 2nd, we had the re-entry of NASA's legendary WISE space telescope. WISE, which is short for Wide Field Infrared Survey Explorer, was launched atop a Delta II back in 2009. Its original mission was to scan the entire sky in infrared for 7 months, which was completed by July of 2010. During this mission, it cataloged 750 million objects, among which were millions of newly discovered black holes and the most luminous galaxy in the universe. Unfortunately, the telescope ran out of the hydrogen that it used to cool the sensitive instruments a few months later, but that didn't mean the end for the spacecraft. NASA assigned it a new mission to study near-Earth objects, and so WISE became Neowise. The lack of coolant meant WISE could no longer observe distant objects, but it was still very capable of studying objects nearby. Under its new directive, the telescope surveyed the main belt asteroids until February of 2011, when NASA put the spacecraft into hibernation. As we now know, that didn't spell the end of the mission either. NASA woke up the spacecraft again in 2013 to look for potentially hazardous near-Earth asteroids, and only 6 days later, it discovered the first. In 2020, Neowise made one of its most famous discoveries, a comet now called C2020 F3 Neowise, which was visible with the naked eye during the summer of that year. It was one of 25 comets the spacecraft discovered during its mission. Neowise observed more than 44,000 objects in the solar system and was the first to spot 215 near-Earth objects. But ultimately, it was the sun that spelled the spacecraft's demise. Increased solar activity accelerated the decay of the telescope's orbit, and without propulsion to stay in orbit, it could no longer continue its mission. NASA turned off the spacecraft's transmitter this past summer, and this week it returned back to Earth. It re-entered over the Indian Ocean west of Australia on November 2nd at 49 minutes past midnight UTC. But Neowise's legacy lives on as NASA is working on its successor, NEO Surveyor, which will look for the asteroids and comets that are the hardest to find. So even though we've lost Neowise, we now get to look forward to the launch of its successor in 2027. Going from one re-entering spacecraft to another, Shenzhou 18 and its crew returned on November 3rd. The spacecraft undocked from China's Tiangong space station at 8:12 UTC and re-entered Earth's atmosphere 9 hours later. During descent, a hole appeared in the spacecraft's parachute, which also happened during the return of Shenzhou 16 in 2023. Now, while that might sound scary, this hole was mostly harmless. The spacecraft is also fitted with a backup parachute and landing thrusters to ensure a soft touchdown. Fortunately, the backup wasn't needed, and Shenzhou 18 touched down at the Dongfeng landing site in China's Inner Mongolia region on November 3rd at 17:24 UTC. This marked the end of a 6-month mission for Ye Guangfu, Li Cong, and Li Guangsu. It was the second spaceflight for Ye Guangfu, who also became the first Chinese astronaut to accumulate more than a year in space spread over both missions. Together with Li Guangsu, he broke another record at Tiangong. A month into their mission, they performed the longest duration Chinese spacewalk at 8.5 hours, during which they installed space debris protection on the outside of the station. The crew handed over the station to Shenzhou 19, who arrived last week for their 6-month mission. Over in Japan, we had the 4th flight of an H3 rocket on November 4th. The rocket lifted off from the beautiful Tanegashima Space Center at 6:48 Universal Time. On board was a military communications satellite designed to use X-band radio frequencies, which was successfully delivered into a geostationary transfer orbit. Later that day, a Soyuz took off from the Vostochny Cosmodrome in eastern Russia. Liftoff occurred on November 4th at 23:18 UTC. The main payloads for this mission were 2 Ionosphera M satellites developed for the Russian Ionizond system that will monitor space weather. The Ionosphera M satellites on this launch were the first 2 of 4 that will monitor changes in the structure of the ionosphere and disturbances of Earth's electromagnetic fields, as well as study our planet's atmosphere. But these 2 spacecraft weren't the only passengers on this flight. There were also 53 small-sat rideshare passengers from various Russian companies and institutions, as well as international customers such as Iran, which contributed 2 satellites to the bunch. On November 5th, we had the launch of SpaceX's CRS-31 resupply mission to the International Space Station. With Dragon on top, Falcon 9 lifted off from Launch Complex 39A in Florida on November 5th at 2:29 Universal Time. Not only was this the 5th flight for Dragon C208, but its booster was also flying for the 5th time. B-1083 wrapped up that mission by successfully landing back at the Cape on Landing Zone 1. Dragon arrived at the station the next day and docked to the forward node on the Harmony module at 14:52 UTC. That docking port had previously been occupied by Crew 9's Dragon, and to make way for the new deliveries, it relocated to the module's space-facing port on Sunday. On November 3rd, the full crew of 4 boarded Dragon to execute this maneuver. Crew 9 undocked from the ISS at 11:35 UTC, and after a short 50-minute fly-around, attached to its new location. CRS-31 brought up over 2,700 kilograms of supplies and experiments to the ISS, one of which is notably made of wood. Now, this is a rather unconventional material in spaceflight, but the tiny Japanese LignoSat is made from it to demonstrate that it can be a suitable material for building satellites. It will be released from the station at a later date. This Dragon also brought about another surprise of its own. In a news conference before launch, NASA announced that the CRS-31 Dragon will be the first Dragon to attempt to reboost the International Space Station. The station is constantly being slowed down by the traces of atmosphere up there, and in order to stay in its orbit, it frequently needs to be reboosted. Usually this is done by a Russian Progress vehicle, but the American Cygnus cargo spacecraft has also had the capability for some years now. Dragon is set to demonstrate this capability as soon as November 8th, so it may have already happened by the time you're listening to this. If successful, NASA will have another way to keep the space station in place where it should be. This might also be useful to SpaceX, which recently received a NASA contract to develop a modified Dragon that can deorbit the station at the end of its life in 2030. With this new Dragon capability, SpaceX gained some necessary experience to control the ISS during that future mission. We also had an Electron launch this week. On November 5th at 10:54 Universal Time, Electron lifted off from Rocket Lab's own spaceport in New Zealand. This mission was dubbed Changes in Latitudes, Changes in Attitudes, and it launched 1 satellite into sun-synchronous orbit. That's pretty much all we know about this mission, as both the payload and the customer were confidential. Some believe that the customer might be eSpace, which specializes in communication satellite constellations. On November 6th, NASA's Parker Solar Probe flew by Venus for a gravity assist. During this maneuver, the spacecraft used Venus's gravity to change its trajectory to get closer to the Sun. This was the 7th Venus flyby since Parker Solar Probe launched in 2018, and the final flyby planned for the mission. During this flyby, the spacecraft passed within 380 kilometers of the Venusian surface and took the opportunity to study the planet in more detail. During a previous flyby, Parker used its Wide Field Imager for Parker Solar Probe, or WHISPER, instrument to study the planet's surface in infrared. These images showed some spots that were brighter than expected, so this time Parker observed the same regions to see if anything had changed. With its last flyby now under its belt, Parker is on a trajectory to get closer to the Sun than ever before. It's set to reach its perihelion, its closest approach to the Sun, on December 24th. It'll then get about 6.2 million kilometers from the Sun's surface, which is closer than any spacecraft has gotten to our star. At least 2 more of these perihelia are planned for the remainder of Parker's mission. Wrapping up the week on November 7th, we had a Starlink mission from Florida. Falcon 9 lifted off from Space Launch Complex 40 at 2013 UTC with 23 Starlink V2 mini satellites on board. This was the third flight of booster B-1085, which also flew the recent Crew 9 mission. The booster successfully landed on the deck of SpaceX's drone ship Just Read the Instructions and is now on its way back to port to get ready for its next flight. With this launch, SpaceX has launched a total of 7,236 satellites, of which 659 have re-entered and 6,075 have moved into their operational orbit. Going into next week, we'll have a Chang'e 2C launch on November 9th. The mission is expected to lift off from the Jiuquan Satellite Launch Center around 3:40 Universal Time. No information about the payload has been released at the time of recording. A few hours later, Falcon 9 is scheduled to launch a Starlink mission from Vandenberg. This time, it will carry 20 Starlink V2 mini satellites, and 13 of those have direct-to-cell capability. Liftoff is expected during a 4-hour window starting at 6:14 UTC. Over on the other side of the country, another Starlink mission is scheduled for November 9th as well. Falcon 9 is expected to lift off from Florida during a 4-hour launch window starting no earlier than 21:54 UTC. On November 11th, Falcon 9 is expected to launch KoreaSat 6A. This TV broadcasting satellite will be launched into geostationary transfer orbit to replace its predecessor, KoreaSat 6. The launch will be conducted from Launch Complex 39A at the Kennedy Space Center, with liftoff planned no earlier than 17:07 Universal Time. The next day, we'll have another Starlink mission from Vandenberg. T0 for this mission is set for November 12th during a 4-hour window starting at 5:07 UTC. That same day, yet another Starlink mission is expected to lift off from Florida. The window for this launch opens at 11:26 UTC and also lasts for 4 hours. And closing out the week, a Chang'e 4C is scheduled to launch another unknown payload from China on November 13th. The mission is set to take off from the Taiyuan Satellite Launch Center around 22:50 UTC. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and I'll see you all again next week to recap This Week in Spaceflight.